Okay, so in this graph here we have minus 2, 4, x squared and 4, 16 are 3 points on the curve y equals x squared. Okay, so all 3 points are located on the red line as shown. Okay, if these 3 points are vertices of a triangle as shown, calculate the value of x so that the area enclosed by the triangle is a maximum, where we're only allowed in between the x values are only allowed in between minus 2 and 4. So this means this point here is a movable point technically. We can move it here, we can move it here, but it has to be in between the two values. The obvious answer would be to move the x value all the way up here or here, and that would make the triangle as big as possible. So that's why we're putting the limit on it. Okay, so what we're going to do is we're going to use the coordinate geometry formula for the area of a triangle. It's going to be half the modulus of x1 y2 minus x2 y1. Please remember that modulus means the absolute value. Now what we're going to do is we're going to extend one of these values to 0, 0. So what we're going to do is we're going to map minus 2, 4 onto 0, 0. To do this, we're going to add 2 to x and minus 4 to y. Then we're going to do the same thing for form 16, which is going to turn into 6, 12. And then we're going to do the same thing for x squared, which is going to turn into x plus 2. So it's going to turn to x, what's going to turn into x? Excuse me one moment. So what we're going to get is x into x bracket x plus 2, and then we're going to have x squared minus 4, and now we're going to do the modulus formula. Okay, so we're going to get a equals a half the modulus of x1 y2, so we're just going to label them x1 y1 x2 y2, so it's going to be 6 times x squared minus 4, and then it's going to be 6 squared times x minus 4 minus x2, which is going to be x plus 2 multiplied by 12. And what I'm going to get here is area equals a half. It's going to be 6x squared minus 24. And this here is going to be minus 12. Technically you can multiply the minus 1 by the 12 first. Minus 1 multiplied by 12 will give me minus 12. So I must get rid of this here and put in minus 12 here. And I'm going to get minus 12x minus 24. Now what's going to happen here is a is half the modulus of 6x squared minus 12x minus 48. Okay, now the maximum all depends on this part here. Okay, so it depends on this part here. Okay, and we'll call it P. Okay, so when this part here is a maximum, the area is a maximum. So what we call it here is P equals 6x squared minus 12x minus 48. Okay, so what we're going to get is the P dx. So remember, this is the differentiable part, and when this differential part is a maximum, the area is also a maximum. So what we're going to get is 12x minus 12, and that will equal 0. Move 12 over, so we're going to get 12x equals 12, and therefore we're going to get x equals 1. So when this is a maximum, x equals 1. Okay, so what we're going to do is we're going to replace x equals 1 into the modulus here. So we're going to get a equals a half 6 times 1 squared minus 12 times 1 minus 48, and what we're going to get here is a equals a half. That's going to be 6 minus 12 minus 48, so it's going to be minus 54. Remember, modulus means absolute value, so it's going to be half of 54. The minimum area is going to be 27. Okay, or sorry, the maximum area is it? Maximum area is going to be 27 units squared. Okay, so that will bring me on to question 26. A rectangle is inscribed between the curve y equals 6 minus x squared and the x-axis. Find the coordinates of C in terms of P. Okay, well, it goes directly up, and directly up means that the x value of C must also be P. Now we just have to find out the y value. So y equals 6 minus x squared for any point on this curve here. If I put in the x value, I can get the y value. So what I know is my x value is P, so y equals 6 minus P squared. So the answer is P and then 6 minus P squared. Okay, write an expression for the area enclosed by a rectangle in terms of P. Okay, so if this is a rectangle, and what we know about this curve here is that it's symmetrical around the y-axis. So this here is 0. Okay, this is the halfway point. Okay, now if that's the halfway point, this point here must be minus P 0, and this makes the area enclosed here 2P. So the length is 2P. Now the height is the y function, and the y function is 6 minus P squared. So our rectangle is in fact 2P by 6 minus P squared. So area equals length multiplied by width, which is going to be 2P multiplied by 6 minus P squared. Hence find the value of P, which makes the rectangle the largest area. So we can multiply this out quickly, and we get A equals 12P minus 2P cubed. We need to find the ATP, because we need to find out its maximum, which means a turning point, which means 12 minus 6P squared equal to 0. Bring the 12 out the other side, and we're going to get 6P minus, bring the 6P squared out the other side, excuse me. 6P squared equals 12. We're going to get P squared equals 2. P therefore equals the square root of 2. Hence find the value of P, which makes the rectangle the large area. The answer for that is P equals root 2. Okay.